So I'm Mike. They've decided not to introduce me because I told them not to. And so if you were here last year, I talked a bit about cloud because that appears to be my thing and I'm just typecast. And again, my cat features prominently as cute this time. So this I've chosen to be generous and call you all professionals. This is about S3. Last time I kind of boiled the ocean. I talked about everything that Amazon offered in terms of security services. This year I'm going to talk specifically about only one service. So buckle up. This is going to go quick. S3. Who's used S3? Half the room, we'll call it. Who thinks they really understand S3? So with like 3 half hands. Awesome. Perfect. First question. What is S3? Any ideas? Okay, correct. It is 3 S's. So acceptable answers are things like object store, apples are objects, oranges are objects, cats are not objects if you've ever owned one. An Amazon service is another acceptable answer, and simple storage service is, like these are all fine things. But there is a correct answer, and it's key value store. S3 is one thing, and this is critical to understanding the nuances of how it functions and the functionality that's layered on top of it, is you have a key, it's a string, and there's a value. A blob, metadata, whatever, but that's at its core, that's what this thing is. Well done, PowerPoint. So, brief history. This is an actual exponential curve, so you can see what exponential looks like. And based on Amazon's blog posts, news releases, adoption of S3 in terms of object counts in the service has been exponential for the last 11 years. So it was released in what we call mid-2006, and today we have 230 trillion objects in this service. And this is exponential. It has basically done a vertical thing over the last few years, and it will continue to do so if history is any indicator. So what's so magic about it? Well, S3 compatible APIs is a thing you're going to hear a lot if you look at other object store services, and there's a ton of them, which means this is kind of the benchmark. It runs the internet. Anybody remember what the internet did when S3 broke in US East 1 in 2017? Slack didn't work. All of your favorite websites didn't work. Nothing worked. I realize you can't read those, but hopefully you can see the icons. Single customers have trillions of objects and exabytes of data in this service. So however big you think you are, you literally don't matter on the grand scale of the service, which means you get to leverage economies of scale for free. Can't even read my notes. And a single bucket can handle 3,000 transactions per second. And those are writes. Reads, that's a whole separate story. If you want 10,000, you just call up Amazon and say, hey, I expect a big load coming in. Can you warm up my bucket? And they go, sure, and hang up the phone on you. This is one of those things where magic just happens. So an S3 bucket can handle over, aggregate throughput is practically unlimited. I have pulled over 100 gigabits out of a single bucket into Lambda functions, S3, EC2 instances. So aggregate throughput from these things is practically unlimited. You can do anything with this stuff. There's no limit on the number of objects. And you can directly serve websites from it, which we know because people do it all the time. I do it. And it has legendary durability. How many nines of durability?
SLA is crazy.
So it's 11 nines of durability. Less availability than you might think, but in practice, somewhere around 5 or 6. So it's a prototype for a lot of different services. So S3 is this one. Google Cloud Storage, Blob Storage, DigitalOcean, MinIO is the free one. It's open source. IBM has theirs. Dell has theirs. I don't know who would use Dell's object store. I'm looking at the guy at the back of the room. But S3 is the prototype. So moving back up the scale to just the general concept of object storage, some primers on it, core concepts. Buckets are the highest level structure in an object store. Everything goes into a bucket, and buckets represent the where you attach functionality. Objects go into buckets. Prefixes are shared starting strings for objects, so it lets you filter them. Because these are key value stores, there's no good way to search the key space. That's not how they're built. So there are other sort of hacks and workarounds that they provide. And ACL is both on buckets and on objects. That allows you to control access and all sorts of other stuff. So, buckets. They're the top level container. They contain a whole bunch of stuff. They have a name, and generally it's in a global namespace like DNS. So this is why S3 is challenging, is because your bucket names live in the DNS namespace. They're easy to enumerate, and they're easy to check and see whether or not you have stuff in them. So buckets hold objects. They have an ACL, which controls access to the bucket, and sometimes, for some amounts, access to the objects in them. And sometimes, if you're lucky, a fine-grained policy lets you layer on top of the ACL and on top of other things. And they provide the functionality. So versioning, website serving, all that sort of stuff is attached at the bucket level. So the bucket provides these to the objects in it. Objects have a key and a value. And frequently, user metadata, that's usually like a key value something that's attached to your value in a key value store. So, you know, hey, here you like object stores. Here's an object store in your object store. No? Okay. And objects usually have an ACL, and we'll see later when I dig into S3 specifically what that means. Prefixes are, these are just a simple thing. They're shared starting strings, and I'll show an example of that later. So prefixes provide efficient ways of applying a policy or something to a large group of any number of objects by applying it to a prefix. And again, I'll show an example of that later. And they, like regex and what you're used to in listing objects in something like a file system, they don't apply because, again, there's a key value store, and they're mapping keys and hashing them. They're not necessarily listing and indexing them. So things get interesting when you want to do large-scale listing on buckets with billions of objects. ACLs and permission boundaries. This is where it gets fun, and this is where people usually end up screwing up. And that is, ACLs control access to buckets and objects, but crypto also controls access to buckets and objects. So you can layer on an ACL, a policy, and a cryptographic boundary, and whether or not you can do an operation on an object in a bucket depends on the intersection of all of them. And that's something that people it's difficult to wrap your head around the first time you see it. So I'm going to talk a little bit about that on S3 specifics later. So an S3 semantic workflow. I create a bucket. I do something with the bucket, like a configuration policy. I enable functionality I care about, like a website. And then I add an object to it, and then I configure security on the object, optionally. I can do that on put, I can do that later, all sorts of fun stuff can happen, but that's the basic workflow of an object store. So we're going to get real, we're going to talk about S3 specifically. I want to leave time at the end for questions, so hopefully this, if you have something that's interesting or something you want to learn more about, there should be time at the end for questions. So S3 has 6 main security mechanisms available to it. ACLs, bucket policies, server-side encryption, access logging, durability, and there's something there, and ownership. So these are 6 different ways of controlling what you can do with what, in what, when, and why. There's no way to screw up the intersection of 6 different mechanisms for something, right? No way. No way. So, bucket ACLs. Bucket ACLs provide a summary, so you can't read it, unfortunately, but this is your AWS account. This is what your account can do with this bucket. And here they control access to 4 different permissions. The ability to list objects, the ability to write objects, which includes delete, reading bucket permissions, and writing bucket permissions. ACLs provide no explicit deny mechanism, only explicit allow. If you're not specified, it is an implicit deny. This is important for later and how the different mechanisms intersect. So you can grant these permissions to yourself or see what's been granted to you if this isn't your bucket. That talks about ownership. We'll get into that. And you can grant these permissions to other accounts if you own the bucket or have permissions to grant these permissions. You can grant them to everyone. And this is what people usually check. They open up all of these to everyone. Don't do that. unless you know what you're doing and know explicitly that you need to do that. But generally speaking, that's not required. That's how people end up in trouble. And you can grant them to a log delivery group, which lets other Amazon services deliver logs into your bucket. So for things like CloudTrail and Amazon-specific logging services, this lets Amazon deliver logs to you. So that's a really nice handy feature because you don't have to open up to others, just Amazon-specific services. Object ACLs, they're very similar. They, again, provide a summary of what your account can do on this object, and they grant access to 3 things. The ability to read the object, the ability to write the object permissions, and the ability to read the object permissions. What's missing? Writing object permissions. That's granted at the bucket level. So this gets really interesting when, again, there's no explicit deny, only implicit, and only explicit allow. So ACLs are easy to get wrong by just going, oh, grant write objects, grant list objects, but then you don't grant read objects. So I can list the contents but not read it. And so people go, oh, well, that doesn't work. And then they're going to get into the next topic. But to finish this one out, again, you can grant these permissions to separate accounts or the public. And so what usually people do is they go public, read, and they do this on every put. So every object has public, read object. So in this case, that's actually yes. The public's allowed to read this object because, and you can't read it, but the bucket is a UUID and the object is a UUID. And I went, you know what, good enough. It's some source code, it's in GitHub anyway. I don't care. I don't want to have to deal with it. Chances of them guessing it is low. So now we're going to talk about bucket policies. This is where it gets really interesting. And this is in the background, which I'll go through and highlight, and it will actually be bigger so you can read it. This is where it gets really interesting. So bucket policies are JSON documents that let you mix and match extreme granularity. So policy made up of statements, and every statement is either allows or denies an action explicitly. So you have explicit deny here. And every statement has the following parts. No, still too small. So every statement has an effect, either allow or deny. Has to be one of the two, can't be both. Every statement has a principal, and a principal is another account or a user in your account. So I can allow another account to do something conditionally and intersectionally with other statements to the stuff in my bucket or to my bucket itself. Every account has one or more actions, and these actions can contain wildcards. So here I have getObject and getObjectACL, but I could have getStar, which allows them to basically have read access to everything, including the bucket, which is handy because for S3, I think there's 50 or 60 different actions you can take. So being able to wildcard your actions and have them named consistently and say getStar means read only, then that's really handy for me as an administrator of this resource. So every bucket has one or more resources. And now it's unfortunate you can't see this really, but this top resource is a specific object. The next one is a prefix, so there's a wildcard in it. And the third one is, ends in 2018 dash. So I can say you're allowed to get any financial reports that start in 2018. And that's something I can do, even though I don't know how many objects that's going to apply to. So the final part, which again, I really should have made these bigger. I underestimated how long this room was. I can have conditions in this policy. So I can say, okay, this applies, but only if you're coming from a particular IP address and not from another set of IP addresses. And I can have multiple statements that contain all of these in one policy for a bucket. And those layer with my ACLs. So this sounds complicated. Awesome. There's documentation and literally a policy generator to help you build these things because they're complicated to remember. So there are tools built into the service and the web UI that help you build these complicated policies because this is how you do things right. So we have ACLs and we have policies, and they layer together as they can grant but not deny. Policies can grant and deny, and an operation is allowed if it is granted by anything and denied by nothing, explicitly. So, super easy. You'll all get it right now. I can stop talking. Server-side encryption is the other part. There's basically 4 ways to do it in S3. There's none, magic, default key, and custom key. Magic is, don't worry about it, but it's magic. And again, these add cryptographic boundaries. So even if S3, the ACLs and the policies grant me permissions to perform an operation, if it mandates that I use a particular key for that operation, which you can do in a policy, and I don't have access to that key, I can't do that operation. So this adds a cryptographic boundary if you're using Amazon's managed server-side encryption stuff. So there's policies on your keys, policies on your buckets, policies on your objects, ACLs. So this all layers together in a way that provides extremely granular, secure ways of deploying these services. And we're going to get into how regularly people screw this up. And you can mix and match encryption policies and stuff within a bucket and objects and all sorts of fun stuff. And you can enforce it. You can say, I'm only going to allow uploads into this prefix if they match this encryption behavior. So you don't have to go and fix it later. You can just deny the upload on initiation and go, nope, thou shalt do as I say, or no upload for you. So there's all sorts of fun stuff you can do. Access logging is a simple one. Configuration is logged by Amazon services. Bucket configuration can be tracked over time. Object operations like gets can be logged at I'll call it best effort, but it's pretty good. Like if you have a bucket with millions of transactions per second out of it, they might miss some. So call it highly probabilistic logging, something like that. Not quite sampling with like a 99% kind of thing. And encryption key use is audit logged separately. So if you have particular keys that are mandated for use in particular parts of your bucket or for particular objects, this is logged and audited separately so you can see what's going on with your keys, who's encrypting and decrypting with what. Data durability, again, 11.9 is durable. If you've got a million objects in there, you'll lose one every 10,000 years. So better than, I don't know, a USB drive. Objects can be versioned, and permissions to past versions are managed separately from the objects themselves. So I can grant any operation I want to the current version, mandate versioning at the bucket, and then whenever an object is clobbered, that past version is no longer accessible to the person that can clobber it. And I can get notifications when past versions are created. So that's a good use case for something like logging buckets, where if an object is clobbered, I want to know that someone overwrote a log file. I don't care that a new one showed up, but if an old one was clobbered, I definitely care. That kind of thing is really useful. How do I know they deleted my data? This is a question I got last year. It's important to know what you're asking. If you have legislative or regulatory requirements for certification that data has been destroyed, make sure you know what you're asking and what context you're asking it in. So in a consumer solid state drive, if you shred-u a file on Linux, it is guaranteed not off that disk because of how the solid state controller works. Because of how S3 works, your best bet is delegate to a certification of which there's, I don't know, a couple dozen. ISO and FIPS and other standards that S3 complies to. HIPAA is another one. Delegate to one of those that is sufficient and call it a day. Because trying to get, I need a certification to Amazon that they deleted my stuff, you're probably not going to get it. Your best bet is client-side encryption, but now you're doing key management. Are you doing key management better than they're doing data destruction? So that's an important question to ask, and I'm not saying that it's the right answer, but it's make sure you know what you're talking about. Call up an Amazon rep, get a good answer from them. Objects and metadata are immutable. You can't change them. All you can do is overwrite them. That's where past versions come in. And consistency of operation varies, but is well defined. On initial puts for an object that didn't exist before, it's immediately consistent. You can read after write. If you're overwriting an object, it's eventually consistent. A second or two tops. Ownership. Every bucket and every object has an owner. Different objects within a bucket need not share owners with each other or with the bucket. So if I own a bucket and you want to put an object in it, you can put an object in my bucket if I permit you. I can't read it unless you allow me to. But because I'm paying for it, I can delete it. That's the basic premise around Amazon, the way S3 handles it and handles ownership. Read permissions are by default restricted to the owner, but I can grant others through object ACLs. And object ACLs are useful but ownership cannot be transferred. So the hack we're working on for that is every time a new object shows in my bucket, and I'm granted read access, I can read it, clobber it with my own, now I own the object. Policies don't apply to objects I don't own. Get it? Good. Never going to screw this one up. So, what could possibly go wrong with a system this simple? Nothing. Hint, it's not because S3 is bad, it's because it's complicated. Like, this stuff is just misconfigured constantly, all the time, without fail. And the reason is people assume that simple storage service isn't complicated. And they assume that it's like, oh, I just need to access this. Oh, well, that didn't work. Go to documentation. This is how you make it public. Awesome. I'm going to do that. No, don't do that. You did a thing because it was easy, not because it was right. And this is not your mother's Linux. It's different. Okay. So this is how an S3 usually works. So don't do this. This right here. Don't do that. You probably don't need to unless you know explicitly that you're doing it. Like the moral, like okay. This happens a lot. In 2017 in the summer, there were at least 10 major breaches that opened up 75,000 top secret or higher clearance documents and 230 million people's records. So what does the internet know about you? Everything. And it's probably an S3, and it's probably public. This happened so much that Amazon added 3 big orange indicators in the console when you do something stupid. It doesn't have to be this way. So this is intended to give you an exposure to how to do things right, what mechanisms exist. S3 is private and secure out of the box. If you do nothing, it is not public. If you only use it within your account, it is fine. Bucket names can be easily enumerated, so don't be lazy when you're doing something. Awareness is most of the battle. So this is intended to give awareness, if not training. If you're interested in more, be the change I want to see in the world, and either get help or educate or read the documentation. The third help point in the CTF is read the documentation. Like, I'm not kidding. Read the documentation. But just in case, there are folks in the room here, myself and others, that are happy to provide assistance. This is not, I appreciate you listening. That's number Wang. Questions? I know that, that was fast, but we have 2 minutes for questions.
Hey, Mike, so you said that there's like 6 overlapping or interwoven areas like where you can define access to a thingy in a bucket. For an idiot like me, if I was trying to make something kind of like a more nuanced access policy, are there tools that you can sort of like feed those, how I would set up permissions for a thingy and then be able to test without actually putting something in the real world? Like, how do you prototype the security access to a thingy in a bucket without actually implementing it?
Yes. 3, so the question was, how do I prototype my access policy and my permission policy without making it live and accidentally making important stuff public? So 3 things. 1, read the documentation. Tons and tons of examples exist in documentation for different use cases. 2, there are policy generators on an Amazon site. There was one at the bottom of the S3 interface, the console itself, the web console, and it will help you generate policies and step you through in a GUI fashion what you want to do. And the third one is there's a policy tester. So you can take the policy you've built, say, test this policy, and then put in conditions like, hey, if I am X, how will this policy affect me? So if you have 20 different statements in a policy, it may be non-trivial to figure out how they overlap, especially if they're written by different people. So this policy tester will help you validate policies for different use cases. But as far as semantically, hey, my business logic is X, how do I do this? Your best bet is an expert human. So there's some stuff to help you muddle through, but at the end of the day, an expert human is like, you're not going to compile a kernel yourself if you've never touched Linux. That's the best example I can get. Any other pressing questions? If not, I'll be kicking around. Okay. Oh, wait. Was that a heckle? Absolutely. I'm serving a website or I'm making available a public data set. If you would put it on Twitter, it should be public in your bucket, but your bucket probably doesn't need to be public. A prefix could be public. So you can serve a website out of a bucket, and the website's prefix can be public, but the bucket can still be private. So if you're going to make a bucket public, it's because you want to make an entire namespace public, like you would make a GitHub account, like every repo in an account kind of thing. The account would be equivalent to a bucket. So yes, but very few. Okay, that is it. Thank you very much. I'll find you after.